Hello everyone. Welcome to this video series on cryptography and network security lab. So today we are going to look at program 13. So before that, like and share the video and also subscribe to my channel for notifications about latest videos. So in this program, the aim is to generate a message digest using MD5 algorithm. So in the previous video, we have seen the hashing algorithm called SHA-1. In this, we are going to see another algorithm which is MD5. Okay, so MD5 was really popular a few years back, but now it is not being used because of some vulnerabilities found in this algorithm. Mm, so if you have seen the previous video, you can skip this. Otherwise, you can continue. So a hash function takes some input, okay, and generates a fixed length string called hash. This hash is also called as digest. Okay, so if you see the second example, the hash function is taking the red fox runs across the ice and it is converting it into this hash value. Okay, and if you see the third example, in the second example we have changed runs into walks and we got completely another new hash value. Okay, so even if you change the input text a little bit, even it is one character change, the hash function is going to give you completely another new hash. Okay, now such functionality can be used in digital signatures, which is used to verify whether a particular message is being received from the intended sender or not. It can be used for storing passwords securely, and finally, it can be used in secure communication protocols. Okay. Right. Now something about my MD5 algorithm. So it is called as message digest algorithm. So you can think of 5 as the version. Okay. So it is a one-way cryptographic hash function. That means from the input you can get the hash value, but if you have the hash value, you cannot get the input. Okay. That is called one way. Okay. So the output of MD5 is 128-bit hash value. So as I told you in the previous video, the hash value is usually represented in hex format. Okay. So in hex format, that is hexadecimal format, every character occupies 4 bits. So if you multiply 32 into 4, you will get 128. Okay. So if you see a MD5 hash value, it contains 32 hexadecimal characters, right? Okay. So MD5 was developed by Ronald Rivest in the year 1991. So this person developed this algorithm to overcome the limitations of the previous algorithm, which is MD4. Okay. Now this is the internal structure of MD5 hash algorithm. So I am saying this again. I mentioned this in the previous video. So we are going to see only the overall structure of the algorithm. We are not going to look at all the internal complex details. Okay. So just like SHA-1, MD5 also works with 512-bit blocks. Okay, so if the given input is less than 512 bits, the algorithm is going to pad it, add some extra data so that it becomes 512-bit block. Okay, now some notation here. So if you look at this, mm, there are 4 rounds. Okay, these blue boxes, light blue boxes, these are rounds. Okay, so in each round there are 16 operations. 16. So here also there are 16 operations. Here also 16. Here also 16. Okay, so in each round there are 16 operations which are being performed. Okay, right. And if you see here, there is K1 to K16. So these Ks are called as round constants, which are fixed values, which don't change. And if you see here, there is something called M0 to M15. Here also M0 to M15. Okay, these things are coming from the message, original message m. So the original message is divided into 16 different pieces, which is where each piece is 32 bits. 32 bits into 16, this becomes 512. Okay, so the 512 message is divided into 16 pieces where each piece is of size 32 bits. These things are this M0 to M15, which are total 16 message pieces or segments. Okay, so that is the M. And these S operations, these things are shift operations, left shift operations. Okay, so that is some terminology or notations. And so the algorithm begins with taking the message M and then starts with initializing four vectors A, B, C, and D. So they have some initial values which are given by the developers. So they are fixed values initially, and these A, B, C, D are going as input to rounds. Okay, round one, round two, round three, round four. So the values of A, B, C, D are going to change round after round, and finally, after round four is completed, whatever A, B, C, D values are coming from the previous round, that is the last round, those things are added, okay, with the initial values of A, B, C, D. Okay, you can see this arrow. These are the initial values of A, B, C, D. And once you add them both, you will get the final hash value. Okay, so this is the overall structure of MD5. Now let's see what happens in each round. So there are four rounds, right? Let's see what happens in each round. So this is the round structure. So if you see in the previous slide, each round is getting four things as input, right? The values of A, B, C, D. So these are the inputs. Okay. And if you see the output of each round is also again A, B, C, D. That is change values of A, B, C, D. So the output is also A, B, C, D. Okay. Now let's start here. So again some notation. K is round constant, fixed values. Mi is the message word. I told you each message is divided into 16 parts, and S is left shift operation. So this is left shift. Okay. Now whatever value we get as input for A, that is added with the value that is being given as output by the function f. F is a function. Okay, so if you go to the previous slide, we have a function f. Similarly, in the second round, we have function g. Third round, function h. Fourth round, function I. Okay, so the operations in the function are different for each round. So I am not going to the internal details of what happens in the function, but let's see what is happening here. So the input for the function is the values of B, C, and D. It takes B, C, D, performs some operation, and gives some output. That output is added to A. Okay, and the output of this addition operation is again added with M. Okay, Mi. So I value changes from 0 to 15. Okay, and the output of this addition is given as input to again another addition operation where the other input is round constant. Okay, and finally the output of this addition is shifted left. Again, the number of left shift done is different. So again, I am not going into the internal details, but some left shifts will happen here. And finally, the output of this left shift is again added with the B value. Okay, and the output of this addition goes to B, and the D value as it is goes as input to A, and the previous B value as it is goes as input to C, and C value as it is goes as input to D without any change. So the only change here is the value of B, which is the result of all these operations. Okay, so this is the overall thing which happens in each round, right? So this is about MD5 algorithm. Thank you.